cultural heritage documentation procedures are usually addressed to orders of magnitude for architectural restitution scales. Still little is out there for the formalization of small object surveying practices. Several solutions for micrometric surveying applications, including range-based ones, are increasingly succeeding in the task, but the considerable costs for these solutions are directing the interest towards precision photogrammetry. This solution offers the possibility of obtaining three-dimensional coordinates of an object from two-dimensional digital images in a rapid, accurate, reliable, flexible, and often money-saving way. It is noteworthy the possibility of using photographs taken by a digital microscope for photogrammetric purposes. Such microscopes, born for inspection, documentation, and digital metrology analysis, are already popular in the manufacturing and quality control industry as well as in the medical field.
The challenge is configuring a highly performative micro-photogrammetric system using the now low-cost and widely available digital portable microscopes. This will imply testing their validity on microscale survey, overcoming operational difficulties, and considering the limitation which could compromise close-range photogrammetry. Not very high resolution, no wide dynamic range, narrow field of view, and shallow depth of field.
In this work, the authors will focus on the systematization of individually available hardware tools in order to explore microscopic photogrammetry and define a standard procedure for the acquisition of 3D printed replica of a tablet with cuneiform writings. Its dimensions are approximately 20 by 22 mm, and the characteristic well-shaped impressions have a depth of 1 to 3 mm.
To achieve an adequate descriptive quality and evaluate result soundness, the survey was conducted with two different Dino-Lite portable digital microscopes. Quality, speed, and cost-effectiveness of this first method were then compared with the data obtained from a Nikon full-frame camera combined with macro optics. All photogrammetric results were compared with an active sensor, the scan-in-a-box structured light 3D scanner used as a reference.
Digital close-range photogrammetry exploits several photos taken from different viewpoints for accurately measuring objects and build a digital 3D model. One of the critical issues, especially at submillimeter level, is the need to include in the scene metric references or calibrated objects to optimize, align, and for scaling procedures.
For this purpose, the authors designed and built a calibrated surface consisting of a PLA plate obtained with 3D filament printing, characterized by an orthogonal pattern of 99 truncated cone holes, the coordinates of which, in a local reference system, are therefore known to the operator and can be imported into the photogrammetric project and used as a constraint point grid homogeneously distributed through the whole area to optimize camera alignment.
Using the digital microscope housed on a vertical bracket at a fixed angle, a series of images with sufficient overlap can be taken just by sliding the calibrated plate manually once the magnification rate has been chosen. The compared model for this first experimentation, universal and high speed, belong to two different categories, both in terms of technical characteristics and special features, consequently falling into very different price ranges. Both models were combined with a 3D plate system, fixing the microscope in a special Dino-Lite RK10EX stand and connecting it to a portable workstation. Hence the acquisitions were carried out with the same magnifications operating with a dedicated procedure.
The validation of Dino-Lite digital microscope results was supported by a photogrammetric survey performed with a Nikon D8110 combined with a 105mm focal length micro-Nikkor lens and a 3D plate calibrator suitable also for digital cameras.
The instrument employed to have a reference model and check the overall geometrical quality of the photogrammetric reconstruction is a scan-in-a-box, a system equipped with two high-resolution industrial USB camera and a high-definition light projector. The comparison of the procedure adopted to digitize the cuneiform tablet with the various technologies includes consideration about the difficulty with the current 3D configuration and camera setting in acquiring the two sides of the object in a single set of photographs, a problem related to the acquisition geometry and the calibrator shape.
The management procedure of the images in Microsoft Metashape for data and products obtainable with microscopes, in absence of eCAADe data, the lack of which must be considered as a further detrimental parameter for the alignment processes.
In addition, to provide a robust comparison for the point clouds, a cloud-to-cloud registration has been performed using the data coming from the scan in a box as a reference. It is noted that the mean and standard deviations do not exceed the instrumental accuracy of the 3 Dino plate, 0.3 mm. Absolutely comparable, and perhaps of slightly higher quality than the scan in a box, are the results coming from Dino Universal.
The final consideration concerns cost, time and quality of output. In this regard, with the cost of a few €100 and a quality comparable to that obtained with by Nikon and scan in a box, the universal microscope is one of the most interesting instruments, with the only drawback that it takes too long to acquire, which can be solved by automating the procedure. The experimental tests conducted with Dino-Lite instrumentation are valid for defining the first approach to the photogrammetric use of USB microscopes. The quality-price ratio of Dino-Lite microscopes, combined with the obtainable high resolution, portability, and user-friendliness, undoubtedly represent the method's strengths. On the other hand, it is necessary to specify that to pursue the survey primary objective, that is the verifiability of method data, some key aspects are still to be more rigorously defined. In addition to software house changes to enable EXIF data to be saved, there are several changes required to the calibrator to allow more points known coordinates to be identified. However, the 3D plate is suitable for objects up to 2-3 mm thickness. For these reasons, and to streamline the acquisition procedures and ensure a more rigorous workflow, the authors are designing an improved system.
Despite the problems within the framework of modern microtechnologies, more interesting ideas for three-dimensional documentation of very small artifacts that would otherwise be difficult to represent prevail from this work in progress.